All right, we're going to do problems number 9 and 10 from the Chapter 3 Self-Test in Geometry. So, number 9 says, what is the measure of the angle formed by the hands of a clock at 10 p.m.? And the fact that it says p.m. is irrelevant almost because 10 p.m., 10 a.m. would be the same thing. In any event, here's 10 o'clock, and regardless if it's a.m. or p.m., it doesn't matter because the hands are still going to look like this. And we want to find what is the angle, the measure of the angle formed by these hands right here. So this angle right here, we want to find how big that is. Well, we know that in the whole clock there are 360 degrees because in a circle there are 360 degrees. So what I'm going to do is I'm going to do 360 divided by 12. I'm doing 360 divided by 12 because all these numbers are equally spaced apart. So if I do 360 divided by 12, which gives me 30, that tells me, or us, that there are 30 degrees between any two numbers on a clock. So 30, 60, 90, 120, 150, 180, so on and so forth. We're looking at 10 o'clock here where we have two numbers spaced between each other. So we're going to do 30 times 2 because we have 10 to 11, which is 30, 11 to 12, which is 60. So we have 60. So therefore, the hands of a clock at 10 p.m. or a.m. is 60 degrees. Number 10 here, we have Al, who's holding a compass that was pointing north, which is what I have right here. Here's the picture from the book. And then here is the picture that I drew where the compass is pointing north. And it's we have a magnet placed next to the compass equally distant from east and south, so they can see that right here. So the compass arrow is going to end up somewhere right around here in between east and south, equally spaced between those two because it says so. And then needle moved immediately to the middle of the magnet. What is the magnitude of the rotation of the compass? So one thing that may not be clear here that I'll point out is that when the arrow moves to get to this point, it could either move kind of around this way or it could move around this way, and we're going to assume that it took the shortest path, which would be clockwise here. So it went from here, and then it ended up going down there. So this is where it was, this is where it ended up, and we're looking for what is the magnitude of the rotation. So basically, how many degrees did this arrow rotate? Well, if the arrow was here and it rotated to there, this would be from here to here. It might be kind of obvious how big that angle is, or that rotation. It's negative 90 degrees. Now you might be thinking, why is it negative 90 degrees? It's negative 90 degrees because remember, rotations that go clockwise are negative, and rotations that go counterclockwise are positive. So if this arrow went from here to here, it went negative 90 degrees. Now that's not the only distance it went, because it went from pointing straight at east also, straight down in between east and south, and it went halfway in between them. Well, if it went from east to south, that would be another 90 degrees. It went halfway, so that would be negative 45 degrees more. And if it went 90 degrees and then negative 45 degrees farther, then therefore the rotation would have been negative 135 degrees.